The next one is again relationship plot, that is between continuous versus categorical. Till now we have discussed individually continuous variables, individually categorical variables, continuous versus continuous. Now what if you want to show the relationship between one of the variable is continuous, the other variable is categorical? That means this variable is yes or no, or region east, west, north, south. Like one of the variable is categorical, one of the variable is continuous. Then how do you show the relation? Then,
It's gender versus salary.
this is a good example. Gender versus salary. Like you want to show whether there is a equal salary that is given to male and female, or if you want to highlight the fact that male are paid more, female are paid less. If you want to highlight that, how do you show that? Okay, here is the one of the method. How do you show that? You draw the histogram, but histogram for only one variable. Here I am taking this, I mean you can consider this as gender variable, or here the variable name is y, okay, which is taking two values, yes or no. Here this actually y was previously purchased the insurance or not. Okay, this is insurance purchased or not. So there are some customers who did not purchase the insurance, there are some customers who have purchased the insurance. Y is the target variable that has been converted to this y. Now, was there any age difference when somebody did not purchase the insurance? Compare them with the customers who have purchased the insurance. Was there any age difference? Now, I haven't explained this graph to you, but I want to ask you, one is green distribution, one is red distribution. One is green, one is red distribution. Green is for people who have purchased. Red is for people who have not purchased. Can you tell me, can you tell me whether there is any significant difference between them, or there is no significant difference? Almost the distribution looks almost the same. What do you say? Tell me. I haven't told you. Can you make a comment on this? Is there higher age for some people, who haven't purchased, or is there a lower age for some people who have not purchased? See, age is on the x-axis. These are all the counts. But if you see the peak of age, whether they are green or red, both of them have the same age, isn't it? Age value is same. Maybe numbers are slightly higher for red, slightly lower for green, but the peak, like if you see the distribution, whether it is green or whether it is red, it is exactly same distribution. Do you agree with that point? Or if you would have seen like this, if the red one goes like this, ignore, this is not the red one, let's say this is the red one that goes like this, then you can say that what is red here? People who haven't purchased, their age is peak around, like most of the people who haven't purchased, their age is around 56 or something. Those who have purchased, their average age, their peak age is around 35. Are you with me? But here, those who have purchased, their age is also around 35 or 32. Those who haven't purchased, their age is also around 35 or 32. If basically, in simple words, if you see this distribution and this distribution, exactly almost same, then you would say there is not much of difference whether it is purchased people or whether it is not purchased. In the example that he gave, maybe if it is gender male, if gender is female, if this is salary instead of age, if you say this is salary, let's say this is 20k, 30k, 40k, 80k, 100k, then salary is peak, highest for most of the male customers, also getting the salary of 30k or 35k, female customers also around that only. There is no big difference. I think if we see an example where there's a difference, then we will be able to appreciate it. Let us see here. Here also mostly the distribution is same. Here the peak is high for 15 when there is no peak is high for, like, there is no clear distribution here, this distinction. Here also almost same, here also almost same. But the maximum point that I want to make here is when there is a difference in the distributions, you will see one of the graph like this, the other one will be like this. Then you will say there is a significant change. One has a peak point here, the other one has a peak point here. If it is not clear from this, then there is a better way. Then there is another method that I can suggest. What is that method? See, this is a continuous variable. Let me ask that question. Age is a continuous variable. One method is histogram. Agreed. Do you know for continuous variable, is there any other method that you're very comfortable? Continuous
Box
variables, box plot. Perfect. What you can do is you take segment 1 here, draw the box plot for it. Take segment 2, draw the box plot for it. If you see there is a huge difference between the box plots for segment 1 and segment 2, then you can say that there is a significant difference. If the point is not coming from here, what I suggest is take for segment 1 people who haven't purchased, what is their age, people who have purchased, what is their age. I can see minimum value of age, minimum value of say same. Let's say this is a segment. Let's say 50% are falling here, 50% are falling here. Let's say out of overall 10,000 customers, 5,000 customers haven't purchased, 5,000 customers have purchased your insurance product previously. If you see the people who haven't purchased, their minimum age is same as this minimum age. 25% else are also matching, 50 are also matching. Looks like everything is almost same. When do you say there's a huge difference? If this box plot shows somewhere here, then you would say there's a difference. So similarly, there are several other examples, yes or no versus duration, campaigns and all that. Looks like apart from this, there I can see a slight difference. I cannot really see any significant change. What is the other alternative to box plot? If you don't like a box plot, if you want to show it slightly neatly, the other alternative box, instead of box, you can show, what is it?
Bar chart.
No. Box plot is the alternative.
Violin, so violin.
Violin. It has to be violin. It's not bar. So you have to be careful. So that's violins, like violin for segment 1, violin for segment 2, violin for segment 1, violin for. Looks like a true violin, but we can't play. These are the. Once again, this is driven by me. That's why you may not be able to really, give a decisive conclusion. What if I give you a problem statement, whether you can tell me or not, that will decide whether you have understood this or not. First, let us quickly complete this, then I'll give you the problem statement. Okay. This is the histogram overlay. If you ask me, though histogram overlay works, if it looks really confusing, my suggestion is go with box plot method of showing different box plots for different categories. Okay. Or violin plots. Violin is just an option. Okay. Now, let me give you the question. Quickly execute that. Quickly execute that and give me a confirmation. Then I'll explain you the questions related to Roseman stairs and ask you what is the final result that I'm expecting. Done? Nothing complicated in that, very straightforward. Now, here is the business part. Remember, your client or your manager or your business partner, they will not tell you, hey, draw the box plot or draw the bar chart, draw the histogram chart, draw the violin chart. Nobody will give you a requirement like that. Nobody will ask you, can you draw the scatter plot and all that. When you are a data scientist, the question will come like this. Is there any relationship between promotion and sales? There is something called promotion indicator or promotion that we are giving. That means there are some discounts that are run. Is there any relationship between promotion, which is happening to be a categorical variable, promotion yes or no, or maybe promotion has 1 or 2, 3 categories. I think it has only 2 categories: promotion running, promotion not running, promotion running 1, promotion not running 0. Is there any relationship between promotion and sales? Now you have to decide, hey, this is a categorical variable. Sales is a continuous variable. Then I have to go with either histogram overlay or box plot comparison for 0 versus 1. Are you with me? Have you understood this question, all of you? Do not execute as of now. Okay. Listen to me first. That is the first question which you are going to tell me the answer. The second question is there any relation between state holiday and sales? When there is a holiday, do you think sales is high? Maybe there are two variables, again, two columns here, two categories here in state holiday. There is no holiday, there is a holiday. Then you draw a box plot or a histogram for when there is a holiday. When there is no holiday, you will draw a box plot. Remember, this is USA, okay? There we cannot really expect higher sales on holidays. People do take rest. In fact, on Sunday in some of the countries, they close the store, unlike here. So with our assumptions, we cannot go with that, okay? We will see anyway. The third question here is, is there any relationship between day of the week? That means on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, which day has higher sales? Can you draw one box plot for each day? This is a good exercise, okay? Go ahead, do it. Tell me the results. Abhimanyu, I told you not to do it, you're doing it. Okay. One shot, histogram overlay, box plot, violin plot, सब कुछ मिला के promotion versus sales. Let me execute it, but I'll not tell the answer. You have to tell me the answer looking at the output. Looks like it is taking some time for collation and all that. Tell me. Promotion, does it have an impact? Does it have an impact? Promotion. First question answer. Promotion. Looks like it has impact. When there is promotion, when there is no promotion, let's say promotion is 1, which is happening to be red color. I can see a different peak here. Green color. Let's say peak here. Sales versus promotion, yes. So promotions हर जगह काम करता है. Whether it's a developed country, developing country, underdeveloped country, promotion दे दो, offer दे दो, sales तो बढ़ेगा ही, है ना? You can see that clearly. When there is promotion, sales is higher relatively. Very clear on histogram overlay, even much more clear on box plot, even same way your violin plot. Yes or no? Are we clear on this? Any question on this? I think there is not much confusion over here. State holiday. Holiday, does it have any impact? I assume that there must be some impact, but we have to check. Usually in India, holiday has an impact on sales. But there people, I don't know, like store itself might be closed or something. It has absolutely no impact. Carbon copies, isn't it? Holiday versus no holiday, carbon copies. So no impact. This variable has no impact. Third one. Now tell me third one. Third one is day of the week. Does it have any impact? Do you think in a particular day that has higher sales? Yes. I think you have to write 2 comments there. You have to tell whether there is impact and which day has high sales, which day has low sales. That also you have to make a comment. Apparently day 1 is Monday. How can I tell you that day 1 is Monday? Because I have to check the original data. If you go back to original data and check the data set, let's say if you take this date 14/2/2014, day of the week is 5. Let's take this one just to see whether 1 means Monday or not. I will check this origin, since this is anyway original data, so we can check what is this day. It shows 1 over there. So day Monday, 4th February 2013 is Monday. Apparently that is 1. So 1 is Monday. So rest all will follow accordingly. So go down and tell me which day has the highest. Which day has the highest sales? Which day has the least sales? Monday has the highest sales, and which day has the least sales? Sunday have the least sales. Such a surprise. This was truly surprising for me when I worked on it for the first time. I was expecting
I
high.
think one is Sunday, sir.
Hmm?
I think one is Sunday.
Why 02 2013 is Monday? Huh? That's why I got this doubt. I checked one of the days. So I had that doubt. I thought that one is Sunday, like which day is what? So I went to the data. So I have gone to the data. Let's go to Roseman sales data. In the data set, I have looked at one of the data point. Look at this one. 4 to 2013. 4th February 2013. It is given as 1. What is the day of the week? Or let us take one more one, like 19/1/2015. Which day is that? That is given as 1 here, apparently. So if I take 2015, that is again Monday. So Monday is 1 for us. Yeah. 26/05/2013. This will be one more validation that it will be
Sunday.
Sunday.
Coming Sunday.
It's coming Sunday. Yeah. That way. Since this is from their store data, we can easily validate like this. So where were we? We are here. Okay. So what I'm saying is like, yeah, like most of you have given me this. Monday has the highest sales, which is like here, which is like opposite in our country. Monday, Tuesday will be least sales. Like Saturday, Sunday will be our peaks. They will be extremely high compared to, like if we are looking at Big Bazaar data or some other data, we will have the opposite results. But that is a story. Like we have to follow the data. Data wins at the end of the day. None of the arguments will win. That is a story of categorical versus continuous. Are you confident about this? Can you show different categories and their individual distributions? Can you highlight a category when it is different or when there is no difference? Are you confident? Have you understood this? All of you. Any questions on this?